to go to the BC review session.
Too bad Fred's an AP, so he's not coming.
Let's go, Scoob!
Whoa, it sure is spooky in here, Scooby.
Where is everyone? Doesn't the review session...
Ghost! Like Scoob, I'm scared. Let's get out of here.
It's okay, Shaggy. We'll find the ghost.
Alright, gang, we should split up and look for clues.
Alright, but first we should turn on the lights. That's better.
Alright, gang, you ready?
Go team!
Now, Scooby Doo, where are you? We need some help from you now. Come on, Scooby Doo.
So we have the graph of the ghost velocity over a 6-minute period. We can find the displacement from a velocity time graph by finding the integral of the graph. The easiest way to do so is by finding the area under the curve using geometry. For minutes 0 through 1, we can use the formula for a triangle to find that the area for that minute was 1. We then use the formula for area of a rectangle for minutes 1 through 2 to find that area to be 2. Then we use the formula for area of a trapezoid for minutes 2 through 3 to find that area to be 3. We use the trapezoid formula again for minutes 3 through 6 to get areas of 2.5, 3, and 5. We then add up all of these areas to find that the displacement over 6 minutes is 16.5 meters. So the ghost could have traveled 16.5 meters in 6 seconds.
Scooby-Dooby-Doo, here are you. You're ready and you're willing. If we can count on you, Scooby-Doo, I know.
Did you hear that, Scoob?
What happened?
I think Daphne fell.
How far do you think she went?
Let's use calculus.
To find the distance giving parametric equations, you can use the formula for arc length, which is the integral of the derivative of the x function squared plus the derivative of the y function squared. So first, we have to calculate the derivative of the x function, and we get that x prime is equal to negative 2 sine of 2t plus 2t. And then we find the derivative of the y function and get that y prime is equal to 50t plus e. So we use these two equations in the equation for arc length, and we use time is equal to 0 to 2.3 seconds for the limits of integration. And we put it in the calculator to get a final answer of 138.615 meters. So Daphne fell 138.615 meters.
Daphne!
Shaggy, you found me! And I found the first clue. It's labeled clue number 1, and it's a calculus problem.
You're ready and you're...
We start by graphing the two functions to see how they relate to each other. You can use your calculator to find the point of intersection between the two graphs. We find that the point of intersection is at 1.139 and 0.273. So the limits of integration would be from 0, because we are only evaluating the area in the first quadrant, to the x-coordinate of the intersect point, which is 1.139. We know that the formula for area is the integral of the top function minus the bottom function. Y is equal to the e to the negative x squared is the top function, and y is equal to negative sine of 3x is the bottom function. So we put these two functions into the calculator and find the answer to be 1.445.
No, we got a mystery to solve, so Scooby Doo.
We're gonna have to check in that scary dark room over there, but I don't know who's brave enough to do that.
Not me.
Maybe Scooby will do it if we give him a Scooby snack. Scooby! You want a snack? Come here! Come here! Come here!
Scooby Dooby Doo, where are you? We need some help from you now. Come on, Scooby Doo, I see you pretending you got a sliver. You're not fooling me.
We know that the carrying capacity is the numerator of this function, because we recognize this format of logistic growth. We also know that the rate of growth is fastest at half the carrying capacity. So we simply do 600, the carrying capacity, divided by 2, and we find that the answer is 300 people.
I'm tired of looking for clues. I need a bite to eat.
Hold on a second. What's this? I found the other clue!
Oh.
Snack, that's a fact.
We can use Heaviside's method to break this fraction into two parts pretty easily. We cover up one factor and we use its 0 as the x. Once we've decided what the two parts of the fraction are, it's very easy to compute the integral of these fractions. You get that the integral is equal to the ln of x minus 1 minus the ln of x plus 2. Then you have to evaluate it from 2 to 3, which are the limits of integration, and when you solve it, you get ln of 2/5 minus ln of 1/4, which simplifies to ln of 8/5.
Pretending you got a sense.
This clue said to check on the fireplace.
Well, where's the fireplace?
There it is.
There it is! I found the next clue!
What does it say?
Well, we have to do more calculus.
Are you? You're ready and you're
So we know that our step would be 1/2, because we need to get to x equals 1 in 2 steps. So each step will be 1/2. And we know that our first x and y are 0 and 3, because we're given that information. So then we can solve for dy dx at this point by using the given equation dy over dx is equal to x plus 2. So we plug in that at this point x is equal to 0, so dy dx at this point would be equal to 2. Then we have to find the change in y, which is dy dx times the step, which is 1/2, so it's 2 times 1/2, which is equal to 1, and that's our change in y. Then we find y new, and y new is equal to y plus the change in y. So it's 1 plus 3, which is 4. We then repeat the same process using our y new and our x is equal to 1/2 to find that the next y new is equal to 21/4. We end up with a coordinate of 1, 21/4, so we found the approximation of y1, which is 21/4.
The last clue led us to this room, so the ghost must be in here somewhere. There it is!
Oh!
Scooby-Doo, where are you? We got some work to do now.
Not the ghost.
Let's see who it is.
It was me, Fred. I wanted to link clues around for you guys so you could do my calculus for me. And I would have gotten away with it if it weren't for you meddling kids and your dumb dog.